We have got so many questions, okay, related to J examination point of view, NEET examination point of view, including some okay basics of for the board examination point of view. So now we are going to add some more questions, okay, which will boost your confidence. So if you know the chapters that are going to attempt these questions. So these questions we have in young studies in the experiment is shifted from A to adult. So then hinge width decreases, hinge width increases, hinge width remains same, and hinge system disappears. Once the hinge width decreases, so there we will do astronomicals based on this concept. So basically, what's happening? Hinge width decrease. Okay, next question. I'm moving ahead. Alternate bright and dark fringes appears against double slit experiment due to the phenomenon of interference diffractions, interference of reflected waves and none. So interference of reflected waves, interference of reflected waves because of interference of reflected waves. Next question is whether the phase difference between the wave reaching the central phase and the fourth bright phase will be. Yes, those will remember the phase difference between the question talk about phase difference will be 8 pi, okay? Because it's fourth bright phase is n pi, okay? N pi, okay? 2 n pi, 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 so it will be 8 pi. Next question I'm moving ahead. Interference pattern is obtained using white light, then the central bright is dark. It is this. The correct answer is bright fringe nearest the central bright is fringe is violet. Okay. The bright fringe nearest the central fringe is violet. Violet, 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 and violet. Next question I'm moving ahead. In Young's dimension experiment, if one of the slit is closed, the, so these options we have. The correct answer is the central band becomes dark band. So it the Young's dimension experiment, one of the slit is closed. Okay. If you close one of the slit, if you close one of the slit, so what will happen? If you close one of the slits, so what will happen? The central band becomes dark band. Central band becomes dark band. So next we are moving with next questions here is that okay, we have a special two coherent sources S1 and S2 are produced interference fringes. If a thin mica plate is introduced in the plate path of the light from S1, then the center maximum. Okay. So if you are introducing thin mica in the path of S1, thin mica to the path of S1, okay, and then the center maximum. Question is very good. So shift towards S2 and this option here. So basically shift towards S1. So it will shift towards S1. So because the mecha introduced in the path of light from S1. So if you are putting the okay mica in S1, so it will shift towards S1. So take care of this concept. Next question we have is in Young's dimension experiment, a mica plate of thickness C and reflected residue is introduced in one of the interfering beams, then the central branch will be displaced through D, displaced to display this. So the young solution is the thickness T. So basically you are applying a mica plate of refractive index mu and thickness T. Refractive index mu and thickness T. One of the interfering beams, the central thing will displace through. Okay. So in this question, what will be the correct answer? So this will be mu minus 1 T d by d. So question is talking about and then the central fringe will displace through. Central fringe will displace through. So this will the central fringe will displace through mu minus 1 T d by d. If this concept in the brain, next concept we are moving ahead is the phenomenon of diffraction of light was discovered by Francis Fraunhofer Young's diffractions of light is discovered by okay, Grimaldi. So Grimaldi discovered the phenomenon of diffraction of light. Next question I'm moving with the empowerment of light in the shadow region as it passes around a small object is called polarization, interference, diffractions, and scattering. It's a diffraction. It's a diffraction. Okay. Next question I will talking about the phenomenon of diffraction is attributed to only white lights, only sound waves, only metal waves, all the way. So it's actually because of all the words. So the next question we have Fraunhofer's diffraction. In Fraunhofer's diffraction, the diffraction effect in the direction of propagation of light normally is studied the source and the screen are at a finite distances and the wave fronts are spherical and no lenses are required. So correct answer is the source and the screens are at an infinite distance. Source and the screens are infinite distance in Fraunhofer diffractions. In Fraunhofer diffraction, source and screens are at infinite distance. Next question I'm moving at diffraction of light is the bending of light at the source of separation. This Hmm. So, and then bending of light as a suppression and involvement of light. The correct answer is involvement of light into the geometrical shadow of the obstacle place in its path. So, deflection of light is basically deflection of light is involvement of light due into the geometrical shadow of the obstacle placed in its path. Placed in its path. Of the obstacle placed in its path. Okay. The next question I'm moving ahead. A very small object is placed in the path of monochromatic light. Its geometric shadow has mm, bright point at the center, surrounded dark point at the center, surrounded by the alternate bright and uniform darkness. And so, the correct answer will be a bright point at the center, surrounded by the alternative bright and the dark rings. Okay, the bright point at the center. Okay, very small object is this. Okay, placed in the path of the monochromatic light. So its geometric shadow has a bright point at the center, surrounded by alternative bright and dark rings. Next question is, I am moving ahead here is the condition for observing Fraunhofer's reflection from a single slit is that the wave from incident on the slit should be a spherical cylindrical plane. And condition for observing Fraunhofer reflection from a single slit is that the wave from incident on the slit should be plane. Okay, single slit, so wave should be planar. So incident on the slit should be planar. Fraunhofer is infinite distance if you see even a spherical cylindrical, I think it looks like plane. Yes, so your deflection takes place in the case of longitudinal transversal waves and both. Because the correct answer will be both. Either deflection will take place either longitudinal with front waves also showing and light also showing deflection. So that's why. So the silver lining surroundings the profile of a mountain just before sunrise is due to silver lining surroundings the profile of a mountain just before the sunrise is due to interference, deflection, dispersions, and reflection. The correct answer is diffraction. Because of diffraction. It's because of diffraction. It's because of diffraction. Okay. So next question we are moving ahead to observe diffraction, the size of the obstacle. To observe diffraction, the size of the obstacles has no relation to the wavelength. Okay. Should be lambda by 2 should be much larger than wavelength, and this should be an order of wavelength. Right answer is should be the order of the wavelength. Should be the order of the wavelength. Okay. To observe diffraction, the size of the obstacle should be the order of the wavelength. Next question I'm moving with to minimize of differences are perfectly dark and this will not perfectly dark, not perfectly dark of different intensity. Not perfectly dark and of different intensity, and not perfectly dark and of different intensity. So important different intensity. So it is of different intensity. Next question I'm moving ahead is radio waves undergo diffraction under buildings, whereas light waves do not. This is because radio waves undergo diffraction around buildings, whereas light waves do not. This is because okay, wavelength of radio wave is very small as compared to the size of the building. This is a very easy question because wavelength of radio wave is larger as compared to size of the building. So radio waves will undergo diffraction around building, diffraction around whereas light waves do not. Okay, because the size of the radio waves is larger as compared to the size of the buildings. Okay. The next question I'm moving at the structure of the crystals can be studied using deflection of visible light, deflection of X-rays, interference of this, deflection of X-rays. So, structure of crystals can be studied using the deflection of X-rays. Next question I'm moving is do this question. What's the answer for this question? So answer for this question will be Rotate of Lensman is correct. So diffraction pattern is due to interference of light from secondary waves, same wave front, whereas interference is due to the superposition of the wave fluid spread from the same source. Okay, so deflection pattern is due to interference of light from secondary waves of the same wave front, whereas interference is due to superposition of two waves spread from the same source. Here source is same. Here source is same. In okay, interference source is same. In interference source is same. Here we are using secondary waves. Okay, next question. Diffraction patterns due to straight edge contents is an illuminated part. Diffraction pattern due to a straight edge patterns in an illuminated part is alternate bright and dark bulbs and this and the correct answer will be for this question alternate bright and dark bulbs and decreasing width as the order of the band increases. Okay, so alternate bright and dark bulbs and decreasing width as the order of the band is increases. Okay. So next question I'm moving ahead is next question I have in the case of diffraction bands due to the straight edge as we move away from the edge. Okay, the correct answer for this question is okay, intensity of the bright band decreases and that of the dark band increases. So intensity of the bright band decreases. Okay, as we increase the diffraction band due to the straight edge as we move away from the edge. So intensity of the bright band decreases and that of the dark band increases. So next question we are moving ahead. Next question we have is as we move away from the S into the geometrical shadow of a straight edge, the intensity of illumination this increases from this so decreases. So basically, as we move away from the edge into the geometrical shadow of a straight edge, the intensity of illumination decreases. Intensity of illumination decreases. So next question we are moving ahead is okay. All kind of images observed through any optical instrument have undergone okay, all kind of images observed through any optical instrument have undergone interference, diffraction, polarization, and super interference. Answer is diffractions. Diffractions. All kind of images observed through any optical instrument have undergone diffractions. Have undergone diffractions. So all kinds of images objects have undergone diffraction. Next, we will move from the edge of the shadow into the illuminated part of the diffraction pattern due to strict edge. The intensity of the brighter band increases, the dark band decreases. So the dark band increases as we move from the edge of the shadow into the illuminated part of the diffraction pattern due to straight edge. The intensity of the dark band increases. Next up, we have in the case of diffraction pattern due to straight edge, B1 and B2 are the width of the first and second bright band. D1 and D2 are the weight to the first and second dark bands. Then D1, B2, D1, this. The correct answer is D1 is greater than B2, D1 is greater than in case of the reflection pattern. So here is state B1 and B2 are the weight for the first and second bright, and D1, D2 are the weight for the first and second dark. So obviously, width of first will be more either bright or either dark, either bright or either dark. So next question, I'm moving ahead. Next question moving ahead is in diffraction as the order of field increases, intensity of maxima decreases, intensity of minima increases, width of decreases, all of that. Correct answer is intensity of minima increases. Okay. So in the diffraction as the order of range increases, intensity of minima increases. Intensity of minima increases. Okay. Diffraction as the order of field increases, the intensity of minima increases. So next question I'm moving ahead is okay. Both light and sound show wave character, but diffraction is much harder to observe in light. This is because light waves are transverse. So the diffraction is both light and sound show character, but diffraction is much harder to observe in light. This is because wavelength of light is very small. Because wavelength of light is very small. Next question we are moving at in diffraction pattern. The width of any fringe is directly proportional universally proportional to okay, slit width independent of the slit width. No, the correct answer independent of slit width. Okay, the intersection pattern of width of any fringe is independent of the slit width. Yes, so all kind of images observed through any optical instrument, including the human eye, undergoes interference of light, diffraction of light, polarizations, and none. So, you know, diffraction of light, correct also diffraction of light. Next, what we have in tensor diffraction patterns must be spherical, cylindrical, and plane. Question talking about in tensor diffraction. Diffractions, okay. So it can be both one and the spherical or cylindrical. Spherical, cylindrical. Next question we have the polarizing angle of a medium, polarizing angle of a medium, polarizing angle of a medium changes with angle of incidence. Increasing with increasing wavelength, this type also will be decreasing with increasing wavelength. Okay. So polarizing angle, uh, uh, Polarizing angle will be inverse of the wavelength. Okay. Next question here, moving a transverse wave nature is established by interference, diffractions, polarization, and all. So I consider polarization for transverse wave nature is established by polarization. Next question here, moving a transverse wave nature of light was first proposed by Hagen, Fraunhofer, Maxwell, Sensors of transmit Maxwell. The transverse wave nature of light was first proposed by Maxwell. So transverse wave nature of light was first proposed by Maxwell. Next question we are moving the polarized glass is used in some glasses is when this correct answer is reduces glare. Okay, so the polarized glass is used in some glasses as okay, this reduces glare. Next question I'm moving ahead when ordinary light is observed through rotating thick of a terminal crystal, the intensity of the transmitted light is always zero, passes through maximum and zero, remains same. The correct answer is remains same. So here ordinary light is observed through the visiting thick okay, tourmaline crystals, so the intensity of the transmitted light remains same. Next question, which one of the following waves cannot be polarized? The waves sequence of the and this waves cannot be polarized. Waves is the answer. Next other one, which of the following phenomenon is not common to the sound and light waves? Ultraviolet diffraction, polarizations, and reflections. Correct answer is polarization. Next question, we are moving helical structure of nucleic acids can be studied using the phenomenon of interference, diffraction, polarization, and its dispersion. Its correct answer is polarization. Helical structure of nucleic acids can be studied using the phenomenon of polarization. Next, in the propagation of electromagnetic waves, the angle between the direction of propagation and the plane of polarization is okay. In the propagation of electromagnetic wave, the angle between the direction of propagation and the plane of polarization is this the correct answer is 90 degree. Correct answer is 90 degree. Next question we have in case of light waves, the angle between the plane of vibration and plane of polarization. The correct answer is plane of vibrations and plane of polarization. 90 degree again. 90 degree again. Next question, an ultraviolet light is incident on a surface separating two transparent media with different optical densities at polarizing angle. The reflected ray and the reflected ray are the reflected ray and reflected ray. And on polarizing light incident on a surface spreading through transparent media of the different optical densities at the polarizing angle. Then the reflected ray and the reflected ray are okay parallel to each other. This perpendicular. This is the correct answer perpendicular to each other. That is Brewster angles. We already know. So next to perpendicular to each other. Next question we have ordinary light is incident on the upper surface of the glass slab at the polarizer angle. Then the options we have this is the correct answer. The reflected ray is completely plane polarized with vibrations perpendicular to the plane of incidence. Okay. The reflected is completely plane polarized with vibrations perpendicular to the plane of so remember the vibration is perpendicular to the plane of incidence, perpendicular to the plane of incidence. So next process we are moving ahead here is next one we are moving ahead is in a double diffraction only O ray is polarized, only E ray is polarized, both O and E ray polarized, neither O and E. So in double diffraction, both O and E ray are polarized. Okay. Next one we are moving ahead. In the case of double diffraction of light, velocity for ordinary ray is V dot and extraordinary is okay, well, percentage already is done. Okay. For negative response, this one. So in the case of double refraction of light, velocity for ordinary ray is V dot. So correct answer is along the optical axis of positive or negative crystals, BO is less than VE, BO is less than VE, BO is less than VE. That's why we have of the calcite crystal placed over an ink dot is rotated. On seeing through the crystal, one files the crystal dots and one dot and this the correct answer one dot rotating about the other one dot rotating about the other. That's what moving with an ice Iceland as bar negative crystal placed over ink this is ink dot so ink dot rotated about a vertical axis under the eye emotion stick dot a special image and rotating image record. So the question the reference is we have observed 1 2 3 4 correct answer the rotating image appears much further, okay, then it's extraordinary way, okay, much faster. Okay, this is literally faster, okay. So this is much faster, okay, then extraordinary image. This is the concept. Next question I'm moving ahead. Next question is, okay, dichromism is the property where, okay, unequal absorption of ordinary and extraordinary rays takes place, equal absorption of ordinary extraordinary takes place. Plane of polarized rotates, none of these are first answer is unequal absorption, so ordinary extraordinary rays take place. So unequal absorptions of ordinary and extraordinary rays takes place. That is dichromism is the property here. Next question I'm moving ahead is so polarized sunglasses are preferred because they reduce the intensity. It's easy question. Anyone can do this question because they reduce the intensity of light. I hope this is useful for you. So this will boost flexibility preparation. This will improve your eye. And then thank you.